Hello, dear colleagues. I want to welcome you on the first live session of our InfoSec community. Today, we have lots of participants and speakers from different countries. And so let's start then. Today, we have 3 presentations focused on DevSecOps topic. And we will start from overview of DevSecOps by...
Okay, hello everyone. Okay, let's start off. The topic for today is DevSecOps, pushing security to left. So ideally, this talk is scheduled for 45 minutes. We'll talk about why DevSecOps, how DevSecOps, and what are the key components and culture, process, technology things in DevSecOps. And also we'll see ideal implementations, sample workflows, and also we'll talk about myths about the DevSecOps implementations also. So let's quickly jump in. Little bit bragging of myself. My name is Hari Valugonda. I'm a security professional working for EPAM India. I'm certified professional. I have different areas of interest like web, mobile, DevSecOps, and network security. And also I'm a part of Untitled Chapter. I've done trainings and talks at different international conferences. I've delivered around 60 plus security talks. So on left hand side you can see my contact details. That's my Twitter handle. Okay, quickly, there's a big confusion when we talk about DevSecOps. What is the right name? If you see, a few people call it as DevSecOps, few people call it as Sec DevOps. And the third one, DevOpsSec, is very rarely used, but again I thought I would include in that. So ideally, a few people in the meetings or meetups, they ask us like a lot of time, like what's the right word? So I do not have a concrete answer for that, but ideally the name is not such important, but the act of the security pipeline or implementation of pipeline is important. So the well renowned or known is DevSecOps. So let's go with DevSecOps. There is one more theory. I'm just saying it's a theory. Again, they say if the security, that dev, sec and ops, if security is in between of dev and ops, so you implement in security between your pipelines between dev and ops. So such vice versa like sec DevOps. But I don't believe that. Just a theory on that. So for this talk, we will use DevSecOps as a word, which ideally I also don't like as a word. I would love to say security with DevOps. That's the ideal way to describe it. It's my personal opinion. And moving next, what is DevSecOps? It's not a complicated definition. As a textbook definition, it's a cultural movement that furthers the movement of agile and DevOps into security in low-level language, or for our easy to understand, implementing security using DevOps culture and agile methodologies. So where we are implementing security using DevOps strengths. And as in DevOps, for DevSecOps also, there are 3 key categories, what we talk about: culture, process, and technology. We'll discuss that now. So these categories are important because the culture, what we talk in Agile or DevOps, is quite important. So for us, for DevSecOps also, the culture is important as say. In the culture, we see everyone is responsible for security. This is a mindset culture where it's not any individual security professional responsibility of a security of a product, company, or application asset, but it's everybody responsibility. Right? Every person in the company is responsible for security, starting from like a developer to the tester and different areas, right? And next is everything as code. Ideally in the culture, there should not be manual effort or manual thing, like it's not 100% possible, but it should be everything as code to reduce the human errors and automate as much as possible. If you see carefully, the statement is not saying automate everything, right? So it's like as much as possible. So there are limitations for any automation. Again, to see how far we can automate and reduce the human errors. That's what the idea in the culture. And also communication and transparency in the culture. This is key. As to the DevOps, it's also important for DevSecOps. The communication and transparency is key because there should be clear communication and the transparency between all the teams. So that's a cultural part. And increase visibility and metrics. We should publish the metrics to all levels, and also there should be visibility of any act or any result of a process. Again, moving to the process, implementation of secure SDLCs, security pipeline and securing pipelines. Okay, this is tricky again. Security pipelines, we call it as CI/CD pipelines, which have security tooling enabled for security scans. Again, securing pipelines is something like we'll discuss it a bit later, but again, it is also important to secure your pipelines. Like, let's say your CI/CD for security, the motto is to find security vulnerabilities of a product or an asset, but it is also important to find the vulnerabilities in your CI/CD itself. So we'll discuss that in later part. Okay, and the increased visibility, the motto. And shift left approach, this is the ideal key jargon most of the DevSecOps people use, and it's quite important. We need to understand why we do a shift left approach. I have one slide on this. We'll discuss that. On technology stand, the DevSecOps categories, this technology stand, we should focus on what are the technology based security requirements. Example, if you're using ASP.NET, so your security tooling and security profiling or security results or attacks would be different based on the technology. Again, the scaling requirements, we need to understand if a company grows in a wide, if our security CI/CD pipeline can scale to the requirement. And also technologies which have IDE plugins, which is more helpful for us. I will discuss that. Moving next, if you are new to security, I want to spend a couple of minutes on this slide because these are the jargons we are going to use further. And this is called SAST and DAST. So the name itself, as on slide, it suggests static application security testing, which is SAST, and dynamic application security testing, which is DAST. Okay, when we say static, the name itself suggests that the code itself, the scan is running, or the test is running on a static code, which will not give any compiled output or other things. So if you see, it's all about a static in nature. If you have 100 lines of code and the scanner is reading line by line or a set of lines and finding the vulnerabilities. So it could be code or any INF files or any other configurational files on basis. So which is static in nature. So in simple language, we say static, a code. And coming back to dynamic application security, it's a opposite to SAST. This is also called as black box testing. So in short language, what we can say, this testing includes a exchange of data. Example, we send some data to a particular application, asset, or any device where it responds us back with a result. So there is exchange of data, and that's where it's dynamic in nature. So we test the application sending a different kind of payloads or tags, which we see how the application reacts for each of us. So it's dynamic in nature. So in short, to move further, we should understand SAST, DASTs as a key jargons. We will be using these two words in next slides. Okay, moving next. Shift left approach. I believe this is a world famous movie called Bahubali. I apologize if somebody did not watch this movie. This is an Indian movie again. So on left hand side you have one person, and on right hand side you can see there is a discussion happening in open field. So I'll explain the analogy what I'm trying to explain here, the shift left approach. So the movie plot is such way, this on left hand side, the person you're seeing is a thief who steals the maps of the kingdom. On right hand side, the maps will the maps which you stole is creating this havoc, right? There is a war and there is a discussion happening. So what my point is here clearly is, if the physical security of that maps were being protected, they could avoid this scenario on right hand side. So if you see, I put security team in red color and dev and ops teams on the other hand side, and I made security teams as villains here because most of the dev teams doesn't like security teams. It's again my personal opinion. So shift left approach in the analogy is, we should implement security on the left hand side like in SDLCs, right? Example, if you want to do a pen testing on the UAT or a pre-prod stage, you should be doing as early as possible. So the security testings the security approach and testing will start as much as left possible. We'll see a slide next for that. So this is shift left approach. Okay, my favorite slide, security with DevOps. Now it's easy to say again. A lot of people ask, like, how do we start DevSecOps, or how do we implement DevSecOps, where to start off? So here is a slide. Again, I don't promise that this covers everything, but again, this will give you fair enough idea. Again, it depends upon individual prospect of a company and also project. Okay. Coming back, there are three phases what you're talking. The understanding phase. We try to understand what's a current SAST DAST process. So if you're looking to implement a security with the DevOps, so try to understand if there is a current SAST or DAST process in place, okay, if any, right? Again, try to understand application stack. If you remember, we were talking about technology based requirements. Yes, that's where we are matching here. That's an application stack. So you need to understand what are the application stacks. Example, you're using Node.js, you're using Python, you're using Perl, or any other like Golang, or what programming language is used, right? Okay. Moving next, it's a scanner capability and limitations. If at all the project or the company uses SAST or DST or one of them, we need to understand if the tool capabilities, like few tools have limitations of not finding vulnerabilities which need to be found. So we need to assess the security capability, scanner capabilities and limitations. Dev team security knowledge, it's quite important part because we also need to understand if dev team understands security vulnerability. Let's say an example, if security scanner founds a bug and the developer do not have idea what the bug is, so it's a big gap. So that's where we are going in understanding phase. We are going to find if dev team has the knowledge on security team, if they possess the knowledge, how good they are. And also analyze in understanding phase of security results, existing security results, right? If you have done VAPT for your company or project, if you have done pen testing or red teaming for your company or project, so get the results, see what all the areas, like what are the weak areas in the report. So here in this understanding phase, we get a standard idea or the posture of the company or the project. In the implementation phase, so we need to implement based on sprint and released. We should plan, right? You don't want schedule a CI/CD scan every hour or every alternate day, every week. It depends upon what kind of sprints a project uses, what kind of releases a project uses. So it should be planned such way. Create a scanner profile, a rule set for SAST and DST based on previous results. Again, this is key point. The reason simple, like not every tool can find everything. There could be false positives. I'll explain what is false positive in a minute. So we need to refine our scanner results. Like let's say if you have an example, if you have 10 results out of a scan and there are 6 bugs which are false positive, now you need to refine your profile and rule set to avoid that 6 false positives. Now what is false positives, right? Where if you run any scanner or a tools or a script for the security or any other tools or security, the results, when you analyze the results, you find that the tool has reported a bug, security issue, but actually doesn't exist. So those are called false positive. The name itself suggests is false plus positive. Positive is a positive in nature, but it's false in nature. So to avoid the false positive or reduce the false positive ratio, you should create a custom profiles or rule set for the second run or in the continuous improvement process. In implement phase, we also look into onboarding dev sessions for dev teams. This is important because in understanding, if you see in understanding, we were talking about dev team security knowledge, right? So same case, we want to implement onboarding sessions for every dev team. Why we are doing this is like if developers may come and go for in the project, right? We want every developer who is onboarded is well versed with the existing process of security and where are the results, how we fix it, if there's a reusable code, KB, etc. Again, in implementation, identifying false positive of security results, this is part of it. Ideally, it should be automated as much as it can. And the last one in the implementation phase is conduct security session for dev team. This is a very important step. So it's a security champion or security professional in the project responsibility to conduct security sessions for dev team, make them aware or help them to understand or train them to fix how a security bug can arise and how they can fix it. So on the direct proportionality, like if you conduct regular frequent security sessions for dev teams on a regular results, it will be more beneficial for DevSecOps pipelines and the implementation success criteria. Moving next, it's reporting. There are a bunch of reportings you can add, but I just put it high level. It's a scan time based report. The more the scan time, the more the bugs is the idea, excluding network lag if there is a network issue and other thing. Flaw based reporting, again, if you can see like if your project has high authentication issues, right, then you can say that the authentication flaw is more. Then that's how we can derive the developers need more training on application side, application authentication side. And applications risk reporting, this is for if you are doing risk rating for application, this will also help, this metrics also will help. And what are the benefits? A lot of people ask this question. Again, early identification of vulnerabilities in code, yes. Fix security issues at development stage, very true, and continuously detect and respond. And there are other bunch of benefits again for DevSecOps, like you could find and fix the bugs before it get commits also, right? It's like fixing the bug before even anybody see it, right? Majority of people. Moving next, this is the ideal SDLC life cycle. Again, this varies for company to company, project to project, and the applicability is based on the project need, PA data, and other factors what I'm talking. But again, ideally, this is the ideal way I'm looking at. So in plan phase, plan, code, build, test, release, and deploy. You could add one more phase called operate also. So I'm not adding operate. It would take a bit lengthier in talk. So I only added 6 of them here. So let's see what we are talking about here. Like in plan, we can do threat modeling. Again, threat modeling is to understand the application, decomposing the application, finding the entry exit point, and also trying to recreate how an attacker or what an attacker can do for application. So it's high level of threat modeling, not exact words, but again just for understanding. And ASVS, this is application security verification standard. It's important that every developer follows a secure coding practices and understands what all the implementation need to be done to make code secure. So this is one way you can do. Moving to code, in the code phase, we could do git secrets. I'm just writing git secrets as example. We could write say secret scanning, where lot of developers or other people unwantedly they push sensitive data into code repositories. So we could scan them, find the sensitive data in the repository, and avoid the further consequences there. Again, dependency scan. Again, a lot of projects we use third-party libraries, dependencies. where we don't control them, but again we also want to run a scan, find if there is a vulnerability with the third-party libraries which were embedded into the project code. And in the code phase we can do SAST. Again we discussed about SAST earlier. In the build we do component scan. Component scan, again it's a decomposition of a compiled version of the product or a jar or library, and it decomposes and do the scan there. We can do a security unit test. This is a best process. I believe over the period of time I understood. If you know, again unit test everybody understands. So what is security unit test, right? Security unit test, we could create our custom security unit test if we know the previous results. And let's say my project has sensitive data, and in a particular folder or let's say in a particular people or user roles are sensitive, so I could write a custom security unit test predominantly focusing first them, right? You can do security test case first, then do the DAST later, so that you are focusing on things which you are aware. So you can create a security unit test case. Moving to test, we do DAST baseline. Okay, we'll discuss about baseline. In previous slides, we discussed about DAST. Then what is this baseline? We'll talk about that. And also container security. Nowadays, I believe everybody across the world using containers for handy use. Again, it's easy to use. So we also need to do a container security. In this case, if we are using containers, so I wrote here container security. It could be replaced with any other product security what we are using instead of container. It could be virtual boxes or VMs for you. In the release phase, we do a DAST and a component scan again because we are going to do the stuff again. In deploy phase, we are going to system hardening and application hardening. Okay, system hardening and application hardening. So we'll move to next slides. We have a breakup of each of this plan, code, build, test, release, deploy things there. So before that, I'll talk about DAST baseline scan. Okay, baseline scan is a quick scan. Ideally, dynamic application security testing, a DAST, takes huge time. Huge in sense like hours or more than hours time kind of stuff. So we cannot wait long in the pipeline to wait for the result to move further into next jobs. So there is something called baseline scan, which is non-interactive. It runs the scan against of results or responses provided. So this is, in short, baseline scan is quick scan and can find low-hanging fruits. Okay. In plan code, we talked about threat modeling, ASVS, Git secrets, dependency scans. What we can do, right? We could do threat modeling on security standpoint and right-hand side. Development standards. So we could improve our development standards like secure coding. Make sessions for dev teams, like how do they code securely. And static code analysis we can do. Then security stories. So I'm sure most of you have heard about stories and also security stories. The point I want to mention here is we need to also gather the requirements of our design requirements or requirements for a product which includes security. Example, if you have a login form on your product, which like in design phase, now you could do a security story saying that your login form should have a CAPTCHA present there to avoid brute force, put a soft rate limit, or your password strength should be strong, like 8 or more characters, alphanumeric and special characters. So these are sample. I'm just giving a sample thing. Like you should be creating security stories for each features of your application. Moving next in the build and test, we do dynamic application security testing, infrastructure as code. I believe we have one talk today on this same thing, infrastructure as code. Again, the idea is here to spin a infrastructure or spin a mission using the code, not by a manual method. Again, it's automated process to avoid a lot of human errors there. Container security, we already discussed about this. Using containers are handy, but also it comes with a lot of inbuilt or vulnerabilities. If you are not focusing on container security, then there could be wide opening vulnerabilities on this level. So there is another talk now after my talk. Shanthan is going to discuss on how do you audit a containers. So we are going to cover that in next 15-20 minutes. So stay tuned. Complaints on every build. Yes, I'm sure a lot of people know, like if you build a mission, if you have been a system admin, if you are a DevOps engineer, or if you have built any mission, you spun a mission of Ubuntu or Linux or anything, right? Complaints is one thing, like people will ask, like what all users you got, like who has the access for who have access for this mission, again how many ports are open, or they say like what is the password expiry date, is not the password strong enough. So a lot of like, so you can automate even this in build and test phases. Complaints on every build. In deploy, yes, security considerations we can put up. Secret management is where you don't want hard code your secrets, which are like passwords, keys, tokens, or any other variables which are reusable. Again, avoid typing or hard coding in the code or in any configurational or environment variables unless it is secure. So this is some altogether a different topic of key management system or vault management. So you could implement in deploy stage. And repeatable execution, the ideally this word repeatable execution is applicable for all phases. But again, I just want to touch base this. Any process you want to do in this all phases has to be repeatable and executable. Okay, this is sample DST pipeline. Okay, this again, if you see, again, I did not put SAST. It will take a bit time. But again, this is quite a sample in nature. If you see on the you have developers. So I took one. It could be multiple people. It could be multiple layers or multiple module levels. Again. So the arrow which talks about commit code and bug fixes. I'll explain why we have two words here. So once the developer commits the code, I took example of GitHub. In your case, it could be different thing, right? Again, let's say you could have Travis CI or any other things, GitLab. So once it is there, now it triggers a job, and the Jenkins master, in this case I used as example Jenkins, it could be anything for you. Again, you have a Jenkins master and slave. You have a Docker images, which is security Docker images, because we are using Dockerized security tools. Again, this is a project environment which is going to deploy the code by the Jenkins slaves, and the Docker security image is going to run on the project environment. And DST or security scanners, which are SAST model, are isolated, right? Individual standalone applications can also run on the project environment. The results are being retrieved, and it saves in Artifactory as a to have. You can add versioning and other things to Artifactory. We just want to, if in case we want to see if there is a vulnerability found, we want to see when the code has been pushed off. There are a couple of ways, and this is one of the way where you can find the artifact and see when the vulnerable code has been pushed. And in the point 6, you can see it's moving to reporting portal. It could be anything. For example, defect dojo, where this black guy is security tester. Again, the security tester here is validating security issues. So he's trying to identify the false positives out of the results which has been retrieved from the process. So security tester, once he approves the security issues, validates them, it pushes to issue tracking tool. It could be Jira or any defect trackers. Then the project team assigns to dev team. The project lead or the person responsible from the development standpoint will assign to dev team. So now it assigns to a developer. So now this second phase, what we are looking is, once developer fixes the bug, now it called bug fix, right? No more commit code. That's where we have two text here. So this is a repeatable cycle. Again, one important issue. So if if somebody is asking this question like, is this not a manual process, right? A security person is manually validating it, or if it is automatically validated, why should a security person should be represented in the workflow? Ideally, false positive can be automated as much as it can, but for initial phases of DevSecOps life cycle, like at least a month or two, now a security tester manually validating is ideal process. Once we know the regex, once we know the fingerprint, once we know the response codes and other things, we could automate false positive in the life cycle. Ideally, the goal of this complete DST pipeline is to run on its own, right? So, but from initial cycles, you may need security tester. Once you are confident enough that your developers not creating or there are less number of bugs which is produced by this pipeline, now you can take out 6, this is security person, and automate this one. Okay, I think we'll move next. So if you see, we are talking about project environment here. So what is project environment? Now let's understand this. This is an example. Again, these are like, if you see on the scale, we have increment SAST, DASTs, but again, it could be anything for you, right? If you want to add, if you see there is no component scan in the list, right? If there, you can add any n number of activities on the top side. Let's understand here, right? This is the environments what we are talking, project environments. So local development environment, it could be a developer box where he's writing code. So we want to do a incremental scan, right? And also open source dependency scans, right? Again, in Git develop branch, because we already done incremental scan, we don't want redundant job again. So we may only ask to do open source dependencies. Again, it depends. Like why should we do here also? It depends again. Like it's like if there is a new additions, if you want to do if you want to double check things, then here it is. And Git master branch, again open source dependency we are running, and also we are doing a complete in the branch development master branch, we are doing a complete SAST. Now in pre-staging, again I put an example of staging, pre-staging and production. In your case it could be different, like UAT, pre-UAT, or next staging or staging. It's up to you, but it's a sample what I'm trying to put here. So in pre-staging, you can see we are doing passive DAST. This is baseline DAST what we talked 5 minutes before. Again, it's quick in nature, so we get the result out. And also active DAST, it's lengthier. I mean, it's a time-taking process. Again, so we are doing both in the pre-staging. And in staging and staging our deployments where pre-UAT or UATs, where we want to do active scans, active DAST scans. The reason simple is we don't want to do active scan on production, right? So that's where we are avoiding here the active scans here. It's up to you if you're capable enough, your server can handle, you have load balancers in place, your application can it doesn't impact any users. It's up to you to change this matrix. But this is an example matrix what we are trying to do. So again, in infra scans, we want to do on both level, because again both are both the pen testing and infra scans are more of towards to public network attacks. So it is ideal to have this in nature. So I'm sure there would be a lot of questions or challenges on this. Again, please note this is a sample representation, just to make sure that you could have different development or project environments. You could have different scan types or phases of scan types. You could decide based on what phases or what scan should go in. This is sample just. Okay, I am going to talk about some myths. These are few which I understood, or somebody asked me a lot of times, like, does automation replace manual pen testing? Manual pen testing is penetration testing, right? So from my side, this all the answers for next 5 minutes is my personal opinion again. So again, automation never replaces manual pen testing, because there are a lot of areas where a security tool cannot find issues. Few examples for that: business logic failures, or let's say workflow level of security testing. Like let's say if there is an approval process that has to go phase 1, phase 2, phase 3, then if there is a reject, it comes to phase 1. So there's a lot of workflow methodology which the application cannot understand, right? So my personal opinion on that, it may not replace the manual penetration testing. Automated scanner can find all security bugs? No, because the automation scanner, any automated scanner find bugs based on the definition or inputs or the logic entered into the tool. So it cannot find all the security bugs. DevSecOps implementation results no security bugs. No, it's not true. Again, it will find most of the security vulnerabilities before before going to the productions. Okay, one last thing we should know, or we all should know, is dominoes effect. I say it as a dominoes effect. Now let's say I'm sure most of you have already implemented CI/CD pipelines, and let assume, right, if I built in a CI/CD pipeline with all the phases what we discussed, right, code deploy, code test, build, deploys. Now if I'm using 5-6 tools, security tools and scripts to protect my product and scan it for security, but tell me if your CI tool itself has a security vulnerability. So now what I mean to say, and I want to emphasize this, is like it is also important to protect, secure your CI/CD tooling also. Not only the security tools and the products, but also as part of CI/CD, you should also, like example, if you're using Jenkins, so make sure your Jenkins is up to date and you do not have any known vulnerabilities for Jenkins. Let's say if your Jenkins is vulnerable, now if somebody could exploit your Jenkins, now it is again he could get all the stuffs which Jenkins can do. So I'm trying to emphasize like you should also secure CI/CD pipelines, tooling and the pipelines. That's all I got. Any questions? I think Vitali will moderate. Okay. I'm reading the chat, so give me a couple of minutes. Okay, how about false negative and how to identify? It's a good question. There is no direct way we can do that, but again over the period of time we can build it. So that's where we compare any if you are using any compliance or the third party pen testers. Now you have something which is a benchmarking your security scans. So ideally if you are more focused on the false negatives also, I would rather advise do a manual pen testing, also scan results on the same application, match the differences between them and improvise the security profile for the false negatives. Okay. Yeah, Dimitri, we will send the presentation. We'll upload to the community portal. Okay. Any other questions before we close? Okay, last question I'll take up. How DST different from pen testing? Again, that's a jargon level of confusions. Ideally, people call it as VAPT, VA and PT, and also pen testing. Dynamic application is specific to certain level where we can fuzz or send data, where pen testing can also talk about exploitation level. So if you are talking about granular level differences, both are same in nature unless you look about the output of it. Example, DST may not exploit to a certain level. It can give you a data. This could be vulnerable, or this is what the vulnerability it could be done again. But for pen testing, Mostly it is a manual job where people try to recon, get the data and try to exploit and prove the point of it is exploitable.
Thank you, Hari, for your speech. And now we will have a 5 minutes break before the next speech, auditing Docker containers. Please stay tuned.
Okay, hearing. So, so let us begin with our session about auditing Docker containers. So, this is a brief introduction about me. So, myself working as a senior security testing engineer at EPAM Systems, and I hold OSCE certification, and I am interested into reverse engineering and exploit writing. So this is going to be our agenda for next 40-45 minutes. So where we will be discussing about brief introduction into Docker, and we will also discuss about Docker security issues and Docker audit challenges. And then after we will dive deep into how we can audit Docker containers. So by we'll also have some demos. So I will show you how to audit a few of the Docker existing settings. And finally, we will also discuss about a few of the best practices and kind of checklist that where you can rely on while performing auditing for Docker images. So let us begin with Docker introduction. So what is Docker? So Docker is a containerized platform which allows you to run a code or a machine in a virtualized environment. So it is some kind of similar tool to VirtualBox, or you might have heard about VMware or VirtualBox. Docker is a similar tool, but it runs in a different way compared to VirtualBox and VMware. So Docker is a tool, so that is intended to make job of developers easier to create, develop, and run applications by using containers in an easy way when compared with other traditional virtualization software. So Docker majorly resolves the conflicts that arise in normal day-to-day life. Like you develop a software and you create a configuration and you ask the other person or maybe your colleague to run the same software or maybe code, so they may run into issues due to the changes in the environment. So docker Docker can solve that kind of issues. We use Docker in order to resolve the statements like that used to run in my machine, I don't know why it is not running in your machine. So that kind of practical challenges that we used to face can be resolved by using Docker, because it allows developers to develop or maybe write develop code and can package into as a container and can ship or maybe transfer it as a container to other machines. So the other person who is running the container just need to pull the container and run the container as it is, which which eventually resolves the environment issues. So this is how Docker runs. So it has hardware infrastructure on our which is our base machine, and it has an OS that could be Ubuntu or Windows, whichever it is, and we have Docker installed in that machine. So once we have Docker installed, we can run n number of containers. Here in this example, you can see I'm running a container called web server, container called database, so which is running MongoDB inside it. I am also running a container which is a messaging platform, and I'm also running a few of my orchestration tools inside another containers. All these are individual machines or maybe applications running parallelly on same Docker. So now we will see few comparisons, containers versus virtualization, I mean virtual machines. So you can see on my on the left hand side, you can see the virtual machines where where you can see that hypervisor installed on an operating system. So you see different virtual machines like application and its operating system and its libraries and dependencies. The same, you install another OS inside the virtual machine if you want to run another application, and you install the dependencies and libraries on top of the application. You see, if you want to run two applications, I am installing two operating systems inside an hypervisor. When it comes to a Docker, I'm not installing any operating system again. I just simply installing the application and libraries and dependencies. So which makes, or which might look that this Docker is a lightweight. You can also see the utilization or maybe the memory consumption or maybe the boot up time. So that is which is heavy for virtual machines, and it is very low when compared with virtual machines for Docker. So you can boot the machines fastly, and Docker consumes less memory, and it also the utilization of Docker is very less. So now let us discuss about the security issues in Docker. So Docker is about running random code developed by someone, where you download it from internet and you run it on your machine as root. So you know, as the number of containers running on the system grows, like you pull Ubuntu image, you pull Alpine image, you pull Nginx image, you pull any other database image, whatever you want. So as the number of containers running on this system grows, the likelihood that one of the contained application has a flaw, assume that you have a MySQL container running. So if you have a vulnerability or a flaw inside that container, which could uh, which could result in a breach. So right, once the container is breached, so now there is a concept something called container escaping. So attacker, if he finds a vulnerability or a flaw inside a container, he breaks out of that container, which results in an container escape, where once the attacker or the person who escapes out of that container have more control over the host machine, and he will also have the more control over the containers, the parallel containers that are running parallelly. So once he breaks out of that, so he can control the other containers like engine image or maybe Ubuntu image or Alpine image that are parallelly running on this container. So that is a kind of challenge. And so Docker issues, I mean, this Docker security issues also relate to the capabilities that you provide to a container. It also depends upon the configurational settings. So the different types of flags or maybe switches you use when you run a Docker image. So those all depends upon defining the current security level of a image or maybe Docker container. So now let us see the challenges usually faced by an auditor, right? So auditing Docker deployments can be challenging based on the Docker architecture itself. So similar to the Docker container escapes we discussed, and also the microservices or continuous deployment model with which Docker aligns so well. The microservice architecture or maybe the continuous delivery practices that generally go hand in hand with Docker deployments. So it could have significant advantages for the person who is performing the audits, and also for the companies that are running the containers. The continuous delivery depends on small changes, where we deploy changes very frequently using an automated test infrastructure to reduce risk. So if the security team or the security person can fit these checks into this process of continuous delivery or maybe CI/CD pipelines. So the end result is of a more secure product. But automating the security checks as part of the process allows the security expert to audit or to assess the process itself rather than the settings on each system, because he will also assess the way the CI/CD pipelines has been built, the way you integrate the automated checks inside these CI/CD pipelines. The process is where the real problems generally lie, because when the person, the security expert who is concentrating on uh, the settings of the containers, might miss the process or the maybe the security issues or maybe flaws that lies within the security process of automating the security checks. So but on the other side, these containers also free developers from normal security and operational process, and also provide oversight over the maintenance of what get deployed to the production networks. So let us get into how we can audit the existing, I mean, Docker containers. So whenever we say that we are going to audit or maybe assess Docker containers, so it requires, I mean, we will be assessing or auditing the runtime environment uh, of Docker which is already running, and we will be inspecting the components like Docker images, Docker containers, Docker networks, Docker registries, and Docker volumes as well. So we will individually audit Docker images, Docker containers, Docker networks, registries, and Docker volumes. Now let us see how we can audit Docker images. You know, so usually Docker Hub lets anyone to publish their own Docker images. So there is no way to verify that the images actually do what they claim to do. So recently there have been few incidents that happened where the attackers uh, embedded the images which run crypto miners which are named after popular software packages like MySQL or maybe Nginx or other service. So people mistakenly downloads the images by looking at their names rather than verifying them. So once they download those images and run them, they run the crypto mining software which eventually use your hardware resources and compute or maybe mine the bitcoins or any other cryptocurrencies that attacker wanted to do. So with these kind of threats in place, so it's imperative that images are built in house by starting with a thin base image. So yeah, we will go into that, but let us see how we can audit Docker images by using the functionalities provided by Docker itself. So now I have shared my screen where I'm running the Docker service in behind. So let us see about Docker inspect. When you run Docker images, so it prints out all the Docker images that are available on your machine. Like you can see that these are all the machines that I'm running on my host machine. So now I wanted to see the digest of a Ubuntu machine. So you see I have run Docker images minus minus digest on the machine which has the name Ubuntu. You can see that it displayed the SHA-256 code for two images. So When a person use digest as an identifier, Docker will not only pull the image with that digest, but also calculate this 256 hash digest of what we downloaded and verify it against what we downloaded it or not, right? The Docker, it is also possible for for a person to pull the Docker images by using these uh, SHA-256 digest codes. So this digest provide a number of protections to Docker. So one could be like it removes any attack vector through the Docker registry uh, to change what we were running in. So there could be possibility that there are few attacks where you can overwrite a mutable tag, so which do have impact on effect on the machine that we were writing. So if you chose to pull the images or maybe to verify the images by using this SHA-256 tag, so it is not possible for an attacker to override these mutable tags. So eventually it would not have no effect on the container that we were running. This digest also prevent the possibility of man in the middle attacks. It improves overall stability of the system as a whole. Uh, the simple fact is that digest is an immutable identifier, so we know it can never change. So in such way it provides the overall stability to the machine, I mean containers. It also improves cacheability for Docker pull and other things. you know um, so now we have images now, we have images from the Docker, but you don't know to trust or not. So similarly, as an example, when you sign into GitHub by using GPG keys, right, you will sign that commits, right? Similarly, the containers has something called Notary, which is again an open source product by Docker. So it is a project which allows the images to be signed or maybe containers to be signed. So it is really good to use. So if you want to trust the images or containers or keys, whatever signed by the particular admin who created it, if you choose to trust that particular person. So let us see uh, how you can verify the image. So now I am trying to inspect the trust of the image called MediaWiki. So I just ran the command. Let us see the output. So you can see it is showing all the changes that have been made to this image. So the signed versions, and if there were any tags, it discloses the tags, and you can see the person who signed the image. So repo admin has is the person who committed these images. This is how you can verify the trustworthy of an image by looking at the recent changes that have been done. So if there is this Docker content trust enabled on that machine, so by running this image command, you will see the output 1. So if the output of this command is 1, it means that the container trust on this machine has been enabled, so it allows you to sign the images. So now looking for the known vulnerabilities of the Docker images at runtime. So most of the containers in Docker Hub use base containers, right? Whenever you are developing your own Docker image, you tend to build your image on a base OS called, generally the base OS will be Alpine. So if you want to build a lightweight container or image, so you pull the Alpine OS and you start building the image over that Alpine OS. So whenever you build in such ways, and if those the base images which you are pulling are not frequently updated, then the possibility of having vulnerabilities in the old version of base OS is very high. And when you run the images of old outdated version, the images might contain vulnerabilities, which makes your Docker containers vulnerable. So there are a couple of tools which allow you to assess the runtime configuration or installation of the images or the operating systems that you are running inside a Docker. So one such tool is called Claire. So Claire is an open source project for source code security analysis for vulnerabilities. Uh, they maintain a vulnerability data which is continuously imported from known set of sources, and is correlated and indexed with the content of the Docker, I mean OS versions. So it is an open source where if you want, you could give it a try. So we will be seeing a demo on vulners.com because of the time constraints. So installing and showcasing vulnerability on Claire is a little bit time taking process. So now I'm inside a container I'm running a container called Docker. So sorry. So I'm running a Docker command which allows me to run into bin bash. Now I can write any commands like ls. You can see I'm inside a Docker now. I'm not inside the my host machine. So now you can run a command like this, which is available on the website. So you go to vulners.com and you go to Audit. So they allow you to select the operating system and you copy the command that they were printing here. So this is the output that is being generated. So copy the command, output of the command, copy them, paste it here and run next. So you can see no vulnerabilities were detected in 89 provided packages. So this is because I freshly downloaded this Ubuntu machine and I have updated it, and everything is up to date. So just for the demo, I have the command executed from older machine and saved it in my notepad. So we will try to see what would be the output if I run that out. So pasting it here and next. You can see, right, it is the vulners has detected that one of the library I'm using is outdated, and it is having some vulnerability with a CVSS score called 7.5. So now as a developer I would be fixing these vulnerability in order to be maintained as secure. The similar way, the Claire can also you can also run Claire, where it is, as it is an open source, everything has been documented clearly. So now we will discuss about Docker volumes and network. The Docker is something called immutable structures, like so whenever you start a machine, you do some activities and you stop the container. It means now the Docker is set to 0. So it is like Ghazni, you do not remember what have you done in past. So whenever you rerun the container, it runs from the beginning. So when you want to contain data which is needed to be stored, and when you want to have dynamically generated data to be saved and stored, so there is a concept called volumes, where you can mount the volumes from the external drives, and you can mount it to these dockers and can save the data inside these volumes. So that is the purpose of volumes. And there is also called, whenever you run a docker, it creates its own interfaces. So we will see how you can audit through these docker volumes and docker networks. So you can view the networks that are available in a docker is called, this is how you can view docker network ls. If you want to view in detail about that particular network id, you could use docker inspect followed by the network id. You could see the network range that is available, or maybe uh, ip addresses, ipv6 addresses, and other details of that particular network. So similarly, you can use these kind of interfaces. So in your real-time scenarios where you can use netcat or maybe nmap, and you can perform your information gathering techniques by using these ip addresses, and also detecting if there were any applications or maybe servers running within the a docker local environment, docker local networks. So now the similar way we can also audit docker volumes by using docker volume ls. It lists different volumes that are available. So if you want to inspect each and every docker volume specifically, again, docker volume inspect, and the id. So now it uh, discloses you the mount point, so you can access the data whatever the container used inside this volume by simply accessing it. I'll just let me copy, and I'll navigate into this directory. So now I'm inside this directory. If I see ls, you can see the volumes or the data is stored inside this volume, and this volume is being used by a docker container that I ran previously. So you can see the data that is stored. I can go into challenges folder, and I can see what are the data is available. Cat db.opt, so it is some configuration file. Cat i2 tab, some other random file. So you can notice, right, whenever you run the dockers and you have the contents available, uh, ensure that no sensitive data is being stored, or else you flush the volumes that you created during runtime. So let us also see about the docker runtime and the endpoints. uh, you can view the information about the docker that is currently running by using docker system info. You can also look at the events that are running by using docker system events. You can also assess the runtime of this docker by viewing the contents of docker.service. Sorry. So now let us s- see how they run. Now run the command docker run system info. You can see the uh, available information about the Dockers. You can see that I have total 39 containers available, and 3 of the containers are running and 36 are stopped. You can see the plugins that are available, volumes and network has been used, that have been available on the machine. You can see the various security options that are available for this, running on this Docker system. So yeah, you can see the Docker systems that are events that are running by running the command Docker system events. Seems currently no events are running. We can also see the output, assess the endpoints, right? See, you can see the current configuration of the Docker. You can see this line exec start minus hfd, which says that this command, whenever you see this line not commented inside the docker.service file, it means that you are running the docker daemon API available. So one can directly access the docker services by if this is a publicly accessible machine and running the docker service in this way, you can access the docker container by using docker minus h tcp and the IP address followed by the port. So this is something uh, not a secure way to run, because it allows your docker to be accessible remotely to anyone if he has the IP addresses. So let us check for integrity of the containers. You can diff the docker containers and check the integrity by what are the changes that have been made to the docker file in recent versions, with the current existing version and the previous versions. It is similar to the diff that we run in our GitHub codes. So now I'm running image sorry integrity 1, so which allows me to get into this machine. So I'll be running view commands less minus la cd slash temp touch 23.txt cd dot slash echo docker and files. So let us exit and let us diff the image. You can see the changes that have been made. These are the tags where C stands for create, A stands for append or maybe addition, C stands for create and addition. You can notice the same commands here, that A stands for addition, D stands for delete, and C stands for change. So it shows which file has been which are the files that are been added, which are the files that are been deleted, and the changes. So these three events can be listed off by using this diff. So now we have discussed about the auditing about the docker components like images, containers, networks, volumes, integrity, and other stuff. Now let us see about something called docker bench security audit. So docker bench security audit is a shell script, so which is created in order to perform multiple checks against the Docker container environment. Like if I'm running a Docker containers in my machine, so by using Docker benchmark security audit tool, an open source tool, I can run the script and can see different security issues that are being existing within my current Docker environment. So these are the high level checks. I mean, these are the areas that the Docker bench security audit performs against. So it performs checks against the host configuration and the Docker daemon configuration files. It also perform checks against Docker runtime, security operations, and other Docker SWAM configuration, other configurations. So now let us run this tool and see how it is going to be. So I have just downloaded this GitHub, downloaded this from the, GitHub, and you can see the container ls minus la. So these are the files. I'm just running the sh docker benchmark security.sh. Now it runs, it performs various checks and it provides me the output. You can see the general configuration that is being audited or maybe checked, the check performing against, and you can see the Linux host configuration checks against the Docker daemon configuration files. You can see it is also showing me the containers that are running as root. You can see these are the few other containers that are running with no security options enabled, and it is also showing that these containers are running without any CPU restrictions. So there is a way where you can Docker allows you to restrict the hardware resources that can use by using CPU count, security operations, and other things. So this is how it runs based upon the current configuration. You can assess that this is one more issue that we will go through now, because Docker socket has been shared. So whenever you see this kind of socket is being shared, this is something where you need to pay some attention to, because so there is a concept called mounting sockets uh, from host machine to Docker machine. So whenever you have this kind of configuration enabled, or maybe you are running the machines with this socket enabled, there are multiple ways where which allows that Docker socket allows you to communicate with the host machine. So as it is a simple socket where you can use tools like socket, and you can mount it to the socket and can make TCP connections, and can from Docker inside a guest machine where you can run various commands on the host machine and can uh, execute some malicious commands. So just we ran this, and Linux security model framework. This is Linux security model. This is an architecture that enables mandatory access control policies on modules. So mandatory access control is a type of access control, which it gives more ability, or it gives you the ability to perform an operation in a constrained and a controlled environment. So suppose you run a typical example could be when you pull an Alpine image without any security constraints. You can run multiple shells like sh, bash, dash, or ash. But when you run these the same container Alpine with these LSM module enabled by using other say app armor or maybe say comp, uh, you can control the environment where you run the commands. Like, so without the security constraint you can execute a number of bashes, but while you can control the bash terminal types on running on the Alpine machine by using these security modules, like LSM. So now we will discuss about best practices and kind of checklist that we can follow. uh, this is a checklist that has been extracted from science checklist white paper. So ensure you have good security, host security, like you have the host machine is been up to date. You install on the only the required components. You make sure you harden the kernel. uh, you have these security options like app armor, SE Linux enabled on these machines. I mean, maybe using those security operations, and keep your Docker updated regularly. And also segregate your containers based upon the data sensitivity. Check the image provenance. Enable the Docker content trust enable, which allows you to sign the images, which also allows you to pull the signed images only. So you keep your root key files offline, and have proper backup of signing keys. Please rotate, make sure you rotate the keys, rotate very regularly, and make sure you expire the old keys before once you rotate the existing keys. And you also check the image digest at deployment, like the way we checked by using minus manage digest key. um, make sure you monitor the containers very regularly. You try to capture the host logs, you try to capture the logs from the Docker infrastructure, which allows you to assess or maybe to have a good overview over if there is any security incident happens. Having these logs will be helpful a lot. You make sure that you have these logs enabled. uh, do not run container process as root. When this is one of the key misconfiguration that is usually runs. So whenever you run a Docker image, the de facto you get root access on that Docker container. So once you are a root, you can do anything. But whenever you refer the keyword root inside a Docker environment, it is different, because the Docker allows you to control the root privileges as well. There are certain flags where you can set the privileges by using hyphen hyphen set privileges, uh, or maybe you can also set or maybe restrict the capabilities that a root user can have. So if it is mandatory to run the process as a root, make sure you have that kind of capabilities or mm, other privileges being hardened. So yeah, you also limit the access to run Docker. So whenever you run as Docker, make sure that you do not have any Docker volumes set up which provide the user to host uh, other Docker volumes. So again, remove the setuid and setgid binaries. And this is also one of the key component, like do not store secrets inside a container. Usually the secrets are something like the configuration files or maybe AWS secret keys, which are usually stored in a folder called slash var slash secrets. So whenever as an attacker or maybe as a person you are auditing the Docker images, make sure you also look for slash docker slash secrets file where various secrets might also be stored. So do not store them inside these containers. Store them in a different way. Uh, Make sure you also have secret management systems where where you pull the configuration files or maybe API keys or any keys where you pull them during runtime. And also make sure you rotate your secrets frequently if you use. And there are certain restrictions which says where you should not store the secrets. So such are like environment variables. You are also not supposed to store the secrets inside the volumes that are mount on host. So similarly, when you use store the secrets in similar way, where you store the secrets in volumes that are being mounted from host. Now, as we use the Docker inspect volumes, in similar way, the attacker can access the secrets that you stored inside these volumes. Yeah, make sure you take care about your base image check security. Scan the images regularly for vulnerabilities, and make sure you have an overview about the contents that you are running inside the images, and update the base images regularly and redeploy the containers once you update them. And also limit the container resources. So what container can do, like the similar way what we discussed about the privileges, like you can restrict the kernel calls that a root process inside the container can access on host. You can also restrict the Linux capabilities. You can also restrict the network access that a Docker can have. And one major thing is also about whenever you mount the file systems, make sure you mount them as read only. So there are high possibilities that once you host the or mount the volumes as with the whole writable permissions, the attacker or maybe the other person, the malicious images or containers can write some data into your host volumes. So that is it. That's it about these Docker containing. And again, this is not the whatever the content I presented is not the only content that is limited to. There are multiple ways, or there are multiple methods where you can audit, and there are also multiple components or maybe configurational settings where you can also audit. So due to the time or the time constraints, I just demonstrated only few possible ways where I can present in a uh, less number of time. So there is one thing that I didn't add in this slide and I wanted to mention is there is a website called content.af. So this is a website where where you can practice about the container auditing other things. Uh, you are inside a container, you see ping localhost. So you see there are being permissions denied because these are the containers that are set with few restrictions which allows you to practice or maybe which allows you to practice the container security stuff. There is also some site, I remember it as kata coding. They do also have a few challenges for container security as well. So if you are interested in these container security or maybe uh, container security, please feel free to hit these websites if you want to practice or maybe learn. So thank you for your time. So one question is, what is your experience with enabling SE Linux on a Docker host? So frankly speaking, I do not have these settings enabled while developing these Docker content. So the main thing that the experience that I do only has as a pen tester. So the stuff I do as once I am inside a Docker container, the stuff I do is different from the developer point of view. So like I do not exactly I cannot exactly answer this question because I do not have much experience about that. The only thing I have is the experience I have is once inside a Docker container, the assessing the existing container security, like seeing if there is any Docker volume, volumes, Docker sockets mounted into these volumes, or maybe if there are any capabilities that are being allowed to the root user inside the container, which could allow him to exploit any other, any of the capabilities and can escape from guest to host. Does an application retrieve Another question is, does an application retrieve password from secret management system in a clear text? If then so, then how it can be more secure way than store in environment variables? Uh, so there is something called vault, where it allows you to use the secrets during runtime in a secured way. So and again, it ensures that these API keys, whatever the API keys that are being retrieved, uh, are in encrypted form. While running during runtime, those values will be substituted. And again, maybe I can one thing I can say out of my experience is, using these secret management tools is a better way than storing the environment variables. You can also think this way, right? So as an attacker, so once I am into this Docker machine, so if I use printen, so it prints out all the environment variables on that system. So if you store any secrets inside that variable, it is a easy way where I can look for, right? So when you have these secret management tools, there is a long process that is involved. I need to look what is the secret management tool that you are using, and I need to assess the secret management tool first in order to retrieve the secrets. So now the my scope changes from trying to find vulnerabilities in the implementation of the secret management tool, rather than assessing or maybe finding vulnerabilities in the machine that I am currently in. Any more questions? So if not, I can we can continue with the further session. Vitali, over to you.
Thank you, Shantan, for your presentation. Answering previous questions, I would say that yes, presentations will be shared with our participants, and uh, recording should be available on this channel. And now we will have a 5-minute break before the next session. Thanks.
Hello. Thank you for coming to the meetup. My name is Ihar Charkovsky, and I'm a service delivery manager at EPAM. I'm focused on cloud security, and my colleague is German Pamenko. He's senior security systems engineer at EPAM, with years of experience in security, both on defensive and offensive side. So we understand that you are a little bit tired, so we will not dive too deep. We are going to have high-level overview of security approach to infrastructure as a code. So now you can see what we're gonna discuss today. We're going to discuss the concept of infrastructure as a code and why it is important from a security perspective. We will discuss software development lifecycle and software development lifecycle approach to infrastructure as a code. Feel free to ask your questions. We will answer the most interesting questions at the end of the presentation or in the chat of this translation. Okay, so let's agree that we are talking about enterprise level only. And we will not go directly to infrastructure as a code. We will discuss a little bit related topics to understand why it is so important. But finally, we will put every piece of this puzzle to its place. So let's imagine the classic approach. Either you have a data center, you build it, or you rent it. And if you need to change something in the infrastructure, you have to create a ticket. Then it takes some time to respond for this ticket. And finally, the systems engineer performs manual configuration, or perhaps if this team is rather mature, some scripting will be used. And it is very important that you cannot just go and configure in every case. Perhaps you will need to purchase some hardware, and sometimes it takes very long time, from my experience up to 60 days. In this case, it is pretty slow and it costs because you have to build this building, you have to build all engineering systems. And it is very hard to maintain because you deal with warranty issues, service agreements with vendors, access to data center when you need to configure something. You need to have the hardware reserve, you need to track changes. If we are talking about business continuity, is it robust and reliable? Not really, because you need to have at least another data center. On the other side, you have very well verified best practices, for example, ETIL, COBIT. You have security standards and government and regulation standards, and years of experience in this field. And finally, you may have a very major team, very major vendor, and everything will go smooth. You know, I was in the shoes on both sides for years, but it is not so fast and flexible. If we are talking about cloud migration, the flexibility and speed grows very fast. And what is growing very fast too, it is scale. For example, you may have very much instances, so even serverless functions up and down in seconds or in minutes. A life cycle is very short. Sounds good, yes? Who can tell me how much new features are released every year? As far as I remember, AWS released more than 1,400 new features during this year. Multiple GCP security features were released every month. So service configuration constantly changes. You know, I had a very short project. It was going for 3 weeks, and we met this issue. We met changes in service configuration, and we have to reconfigure our cloud infrastructure, and we had to choose another approach, and we had to perform some patching for application that was deployed to this infrastructure. So this is a challenge too. On the other side, cloud infrastructure is very hard to control. You don't have a transparency. If you look at this site, you may see that misconfiguration, maybe it is the main issue in the cloud, the main security issue, I mean. And the life cycle of instance changed from months and years to minutes and seconds. And now you just can't create enough tickets anymore if you are not a superhero. And there's another very extreme situation when we need to choose a DevOps approach and we need to grow our speed of changing the configuration. So perhaps we will give the full access rights to our cloud engineers. Is it good? Anyone seen the consequences for this? Do you know there are services where you make one click and you are charged for several thousands of dollars? Believe me, there are such services. And what is more important, it is very often DevOps engineers and cloud engineers, they don't have security in mind. So For me, security is a mindset. And security misconfiguration was in OWASP top 10 for years. Look at this shared responsibility model. I believe this is a very important concept. So security infrastructure is designed in a very progressive way, starting from security of data center, physical security of data center, and continuing with hardware security, network security, software security, and finally the processes. It is secured by design with hardening, configuration management, patch and vulnerability management. But if you look at this responsibility model, it was taken from Microsoft, but believe me, other major public cloud vendors have the same shared responsibility model. You can see that who is responsible for data and endpoint protection. In every case, it's a customer. It doesn't depend on which model do we choose. Is it infrastructure as a service or software as a service? And very important issue is that traditional security approach doesn't work anymore. You're not able to use classic asset inventory. You're not able to use classic vulnerability management. You just don't have enough speed and you don't have enough resources to use it. And here comes the very specific class of security tools. It's cloud security posture management. What I should tell you, nearly all major and very famous successful attacks on cloud services are not the result of complex multi-step preparation from the threat actor side. It's just a result of misconfiguration, mismanagement, and human mistakes. And another common issue is a lack of configuration visibility in cloud environment. Very simple and hardly identifiable non-compliance may lead to very serious incident. How to avoid this? Keep track of security posture continuously. Take a look at the diagram, please. The input includes regulatory requirements, industry standards, or specific business requirements. As a result, security policies are developed, which is a set of security controls or simply rules. Very simple but still important example of security control. Ensure that a bucket with sensitive information is not publicly accessible. For sure, it is not possible to control security manually in modern enterprise environment. It should be automated. Cloud infrastructure is already a code. So security controls could be described as security and compliance as code too. And we should treat it as a code too. When we have security policies developed, it's time to distribute it to project environments. If a setting is non-compliant, cloud security posture management solution can take automated action to adapt, including remediation. Continuous approach is needed at all levels, from requirements changes, tracking, which lead to security policy changes, down to automatic misconfiguration detection and remediation. Automation alone won't eliminate all cloud risks. Process and culture changes are also needed. And it is very important to understand that this class of tools are young. They are focused on already deployed infrastructure. And what if you want to test infrastructure which was not deployed yet? So why do we need to perform these tests? That's because of cost savings. There are services that are charged for every deployment, for every activation, or perhaps you need to deploy a very big infrastructure. And it is very important to avoid source codes leaks. For example, many of commercial cloud security posture management tools works like this. You send your infrastructure as code to some private cloud, which is provided by vendor. It is deployed and tested as already deployed infrastructure. In this case, you have to send your code to some third party. And what is very important, you cannot avoid some issues on this side, and it is not covered very good by compliance standards. It is even younger than the whole class of these tools. So finally, what is infrastructure as code? Infrastructure as code, it's a type of IT setup wherein developers or operation teams automatically manage and provision the technology stack for an application through software rather than using a manual process to configure discrete hardware, devices, and operating systems. So infrastructure as code is software-defined infrastructure. For me, it sounds too complicated. I prefer very simple way. It's just managing infrastructure using configuration files. I call it DevOps way of doing things. So what is the outcome of using infrastructure as code? So first of all, it is speed. Infrastructure enables you to quickly set up your complete environment by running a script or running a special tool. You can do it for every moment, from development to production, in every environment, from QA to production, and choosing the environment where you want to deploy. And we can use the entire software development lifecycle more efficient. Consistency. So manual process results in mistakes, and humans are fallible. Our memories fault us. Sometimes we have issues of miscommunication, and we are really bad at it. As you've read, manual infrastructure management may and will result in some issues, no matter how you try hard. Infrastructure as code solves this problem by having the single source of truth as configuration files themselves. And that way you guarantee that the same configuration will be deployed again and again without any mistakes. And very important thing is accountability, because you want to know who made this. We already talked about one click and very big bill. So in this case, it is quick and easy. You can version infrastructure as code configuration files like source code files. You have full traceability of changes, and if each configuration is listed. So no more guessing games. You know who exactly done this and when, which is very important. So please take a look at the diagram. You can see the spectrum of infrastructure as code tools available. And this term describes very wide spectrum. It covers area from creating virtual machine or virtual infrastructure from scratch to post-install activities, configuration management, change management. Very important characteristic of infrastructure as code is idempotency. The result of the operation is the same even if it is applied not the first time. As an outcome, you don't need to check previous steps results. And that's an advantage if we compare it with a classic scripting. And also we should cover a topic of declarative versus imperative. So not all tools are declarative. What does it mean? Declarative means that I need to have this final state of infrastructure. I don't want to know how you're going to do this. Not all tools work like this. For example, Terraform, which is an industry standard, in fact, in public cloud domain is declarative. So what does it mean for us? Together, these characteristics make our life much easier, and they provide us great opportunities for automation. And from the security perspective, very interesting outcome is the immutable infrastructure concept. What does it mean? If you as an engineer need to perform some infrastructure changes, you don't configure existing instance. You just destroy it and deploy a new one. For sure, you need some parts of the infrastructure to be really immutable. I mean, databases or cloud buckets to use it like a persistent storage. And what is very good, you don't have to have any admin interfaces open, and the attack surface reduces. So today we will focus on infrastructure management tools, and we will show Terraform in our demo. So let's go back to the code and talk a little bit about software development lifecycle, SDLC. SDLC is an acronym. It is also called a software development process. It's a framework. It defines tasks performed at each step in the software development process, and it covers a detailed plan for building, deploying, and maintaining the software. At the requirement gathering stage, you collect and develop a document which records expected behavior. At the software design, you create a blueprint, an architecture, which provides developers ideas and the baseline to create a code. You need to understand which models you will have, which functions, libraries, etc., and to compile it together like a software system, because we're creating systems. At the development stage, you finally develop the code, and this time the architecture should be frozen. And at the testing phase, you finally test if it works like it was designed. You need to understand, you need to check all functional requirements, non-functional requirements, maybe some security testing. And finally, you have to deploy it to some kind of environment. And the best practice is to have separate environments for development, for testing, and for deployment, and maybe some stages, sub-stages. So this methodology, perhaps it is the oldest framework, and perhaps it is the oldest formalized methodology for building information systems. And the main idea of it to create it, not in chaotic way, just to bring some order. So we are system engineers, we are DevOps engineers, and we are willing to automate everything. So from the time development team gives us the code and commits it to the time we get it into production. So we will automate the pipeline in order to make the entire software development lifecycle in automated mode. For this, we will need some automation tools. For example, we have a Git repository where the development team will commit the code. Then Jenkins takes over from there, a front-end tool where you can define your entire job or the task. And our job is to ensure the continuous integration delivery process for that particular tool or for the particular application. From Git, Jenkins pulls the code, and then Jenkins moves it into the commit phase, where the code is committed from every branch. The build phase is where we compile the code. If it is, for example, Java code, we use tools like Maven and Jenkins, and then compile that code, which can be deployed to run a series of tests. These test cases are overseen by Jenkins again. Then it moves on to the staging server to deploy it using, for example, Docker. After a series of unit tests, it moves on to production. I believe not only unit test, but the whole stage of testing. So developers often treat testing as an afterthought, and when they actually do testing, the parameters aren't realistic. So good use of automation in all aspects of testing ensures the right tests happen and are effective in ensuring application quality. Automated testing at all levels gives everybody more confidence in the life cycle, saves expenses, allows to create new features faster. Test automation is often sort of much later in the life cycle, which means that teams often test manually and create decisions that make automation much harder in the future. So any DevOps team cannot be 100% productive if it is still has to rely largely on manual testing. And of course, it is very important to define and analyze certain quality attributes manually, but you need to automate everything you can really automate. What is very important, not to deploy exactly to the production environment, because your code could be perfect, but the environment could be not so perfect. And in this case, you need to have some stage environment or test environment, and they should be as similar as possible to the production environments. And finally, when it was deployed, we have to monitor, because it is a very important part of CI/CD process, and it should be automated. automated, I believe. And this is a very important input to analyze if something goes wrong and to fix it as soon as possible, because we can have much details. So finally, a secure SDLC is a setup by adding some security-related activities to every stage. And let's discuss shift security to the left principle. In the past, it was common practice to perform security-related activities only as part of testing. And this after-the-fact technique usually resulted in a high number of issues discovered too late. And believe me, I have seen it multiple times. It is a far better practice to integrate activities across the whole software development lifecycle to help discover and reduce vulnerabilities as early as possible, and effectively building security in at every stage. It is in this spirit that the concept of SSDLC arises, and SSDLC process ensures that security assurance activities such as penetration testing, code review, and architecture analysis are integral part of development effort, and they are implemented in time. And it is not enough to address security only at the end of development lifecycle. For instance, commission penetration testing. There is a couple of reasons for that. For example, cost for fixing is rapidly increasing the later at the every stage of life cycle. And the architecture builds the fundament of secure application. If this fundament is not okay, so application wouldn't be built in secure manner, and it will be very, very hard to fix it. So security needs must be addressed through the whole software development lifecycle. And in this context, we often speak about building a secure SDLC or SSDLC, and that maps security activities on an existing software development lifecycle. So let's make this puzzle complete and discuss and summarize everything that was already discussed. So why don't we use the secure SDLC best practices for infrastructure code? The difference is that we are not compiling infrastructure code, but we still can design, develop, test, and deploy it as usual, but with some minor changes. And yes, we can automate every step of this. Let's discuss infrastructure as code security maturity levels. I have checked the article made by CTO of Checkpoint. They are developers of very good cloud security posture management tools, and I modified it slightly to show my approach to this. So the first stage is manual security assessment. This is a very important stage, and we don't want to miss it, because when we are coming to a new environment, we don't know the real state of this environment, and we can't believe documentation, and we even can't believe our customers, because the interfaces, the services are changing so fast, and it is very hard to understand what is in reality in this environment at the moment. So first of all, we need to perform some kind of asset inventory, but customized to cloud reality. And we need to perform this manual security assessment, and for sure to create some mitigation plan and mitigate our findings. But you know, security is a process. We just cannot check everything, mitigate everything, and say, hey, I'm secure. It doesn't work like this. It is very important to identify security incident very fast, and it is very important to mitigate it very fast. And in this case, we are moving to the next maturity level. It is continuous monitoring, and that's what I was talking about when I was showing the diagram of cloud security posture management class of security tools. And the next one is sandboxing. So perhaps you've seen that I was not talking about unit tests, I was not talking about integration tests, I was not talking about end-to-end tests, because it's very hard to test infrastructure as code and to treat it as classical code. We just don't have good enough, mature enough tools at the moment. If you know such major tools, please share with me. That would be very good. From my perspective, the only way to perform these tests is to deploy the infrastructure. If we perform unit tests, we will deploy some little model. If we perform some kind of integration tests, we will deploy several models or several services. And what's very important when we finish this stage, we still want to avoid our code leakage. We still want to avoid our budget leakage, and we are going to the next level. So we want to apply these SSDLC practices before deployment. And the main tool for this and the main idea for this will be using SAST, because these tools are rather major for infrastructure as code. And we are almost ready to go to our demo, where German will tell several words about tools that we have used in our demo case, and he will tell several words about the demo infrastructure.
So thanks, Igor, for his presentation and a little bit information about our infrastructure that we have prepared for this demonstration. It consists from several EC2 instances in AWS and the WordPress website. So we use Jenkins as a runner and several security and not real security tools for Terraform source code. These tools are TF-Lint, DevSec, and Terraform Compliance. So we have a source code published on Git, and we use Jenkins for applying it using Terraform. So we have prepared a pre-captured demo, and I will comment it for you right now. So you see there are several jobs in Jenkins. We have created 3 separate workloads. It's simple apply. It consists of downloading Terraform code and applying it. Second is full checking and apply, and the third is separate checking for security issues. So for the first, let's just apply downloaded Terraform code to AWS infrastructure. It will take some time, and we'll wait it a little bit. So you see that after successful downloading, Terraform applies this code to AWS infrastructure, and you see it finished successfully. So let's right now check how it was deployed. Just browsing our simple WordPress site. It works perfect. You see it uses HTTP protocol, and we have added some customization with content that is stored on S3 bucket with the EPAM logo. So we also added some redirect to EPAM site, and it works also perfect. Everything is going okay, and from the applying infrastructure, it also works fine. Nothing special. For the first site, it's all beautiful. Also, we have to say that in AWS, we used role-based access for our runner, Jenkins, and we added some permissions, not full admin access. We just added some permissions that were needed for current jobs, and also added tagging as a best practice. Not full admin access, as you can see. So let's return to our separate checks. As you can see, we use different tools. And as I previously said, it's compliance, TF-Lint, and DevSec. And all of them are red. As you can see, they all crashed. So what was the reason? We will discuss it some little bit later, but you can see that we run these jobs and all have failed. So let's discuss about these tools in separate mode. So the first one is TF-Lint. Let's view it on Git. It validates provider specific issues, as you can see, because Terraform plan and Terraform validate cannot find this possible error beforehand it applies. It has over 700 rules, and you can check it if you wish. Most of the rules are general and can check for typos and any misconfigurations and other Terraform best practices. In general, these checks are not security specific and can be used in wide areas of Terraform. For example, some rules of disallowing using previous generation instance types or disallowing variable declarations without descriptions. Full description is available in Git, and it has custom error code statuses, and we use it in Jenkins. And in general, as I said, it's not security, it's just Terraform specific. The second one is Terraform Sec or TFSec. It's also available in Git, and it is more security specific tool, and it can be provided like a SAST for Terraform code. It is flexible. It has several cloud provider specific checks, and it is also flexible, and you can, if you wish, ignore some requirements just using this code in your Terraform code source, because there can be something issues when you use S3 bucket and it needs login for S3. When you define another bucket for login, it also will require login for login bucket, and it's recursion. You can use some exceptions that your code will be applied successfully without any issues, So also this tool covers well-spread and well-known CIS security benchmark. You can just Google for it for PDF file. It is available on AWS site. Let's do it. So just Google the file type PDF, and the first link is CIS Aws Foundation Benchmark. You can check the version. It is the latest one. It is available in public, so you can view it. And for example, we can define some rules, and one example rule is allowing ingress for all IPs for port 22 for SSH protocol. And this check is also included in TF security model that we'll use in checking Terraform code. The last one is Terraform compliance. And this is a behavior-driven development style frame tool. And it is also available on Git, and it has its own site. You can check it. It is a lightweight security and compliance focused test framework against Terraform, and it enables negative testing capability for your infrastructure as a code. For example, you can see some style given, then, when, and this example shows us to define encryption for S3 bucket. It's a declarative manner, so it checks Terraform code that contains some S3, for example, and requirements in this code. You can also visit its own site. There are some examples that show that it's BDD referenced, and there are examples of usage and how you can perform it in your testing Terraform code. You can see that there are different kinds of checks like KMS, encryption, etc. So let's view our job that were crashed. We can go in job, check the latest crash build and console output. And we can find out that there are a lot of errors in each job. For example, here we see 3 bugs in our code. So if we also can create another new workspace if we want to add some tools or just make separate checking, not in one, it's your opinion. So we can also check another failed job the same way, go and build, check console output. But frankly speaking, as for me, it's not so comfortable to read console output in Jenkins in this manner. So we can go in CLI and check the same output of using Terraform scan command for security issues. So we can see here 9 highlighted problems. There are some fully open ingress security groups, no description in resources, no login enabled, also available public S3 bucket, some public IP addresses associated with best-in-host, with ELB. Some of these problems are really from secure manner, some of them are not. But as I said previously, you can check what problems are relevant to your infrastructure. And if them problems are not relevant, you can just make exception in your Terraform code using special phrases from DevSec. These common checks are also, as I have said previously, relevant to CIS benchmark and some other best practices from security and AWS. There are some highlighted. You can see source code with public access with a wide range of IP addresses, with available SSH service also without any filtering. So for the first sight, it's very useful to check very common problems in your Terraform infrastructure code. So another tool that we wanted to show you more deeply is Terraform compliance. As I said, is a BDD frame tool, and in theory we can define every check that we want for Terraform code, for example. If you read some documentation about this tool, for the first, we need to specify a custom feature file, where we can define state of testing. For example, here in our file, we have 4 checks in feature file. You can see that there are some states of given, when, then, and other special words. For example, these checks show that must not be public access to SSH. And another check, there is only HTTPS or 443 for other IP addresses. It's rather simple and easy to read. If we check our code with these checks, we see that there are 4 problems and our code checking failed for this compliance state. So another widespread problem, as you probably know, is credentials leakage or secret leakage. And you can also find it when you hard code your secrets in infrastructure or in other code. And this tool also provides ability to check for this. Everybody, I suppose, know about a tool that's called AWS and Git secrets. It's not just AWS. But in this case, we can substitute Git secrets with Terraform compliance. We define several words like access key and secret key and regex for checking symbols and other figures in these fields. We have not done it in our production, but for demo, we have injected some secrets in our code, and you can see that it was successfully defined. So another thing that we want to show you is public access to some objects that are stored on S3 bucket. Our site has a structure, and our image is stored on S3 bucket. It's public access, and we can see it in source code. So let's go to S3 and check, can we read it or not? We just use any machine with AWS utils, so we can find out that this object is readable for us. What's next? Let's try to write some objects in our S3 bucket that is publicly available for us. We just prepared another simple logo and try to copy it to the bucket. Oh, sorry, it's another mistake, but it will be successfully, I suppose. So it's done, perfect. Let's do ls again, and we see 2 different objects in our S3 bucket. What we will do right now? we will try to make a funny script key deface attack. We just remove our original logo and replace it with another one. AWS S3 commands are relevant to Linux commands, so it's rather easy. We have removed original, and another way we just copy new with the same name of file. Successfully. The final step that we want to do is to check that they are the same files with different names, and the final step is to additionally give permissions for reading these objects. It's just for case. So here we give a permission to read this object from this bucket. Not to be mistaken with the object name. And put an ACL public read. And that's successfully finished. So let's go in other private window without caching and go to our site. Let's view what happened. Another logo. Small, funny deface attack. In the source code, you can see that object is the same. From the same bucket, the same object name. So in this case, we have shown that you should care about IAM permissions with object and object IAM policy when you make it public to read. Because if you made some additional permissions, you can fail and you can get some problems. So let's return to our Jenkins. You can see that there are a lot of errors in our source code, but after it had highlighted errors, we have fixed this code, and there is a full pipeline when we do all three checks of our Terraform code, and only after it's successfully finished, we deploy our fixed Terraform code to our infrastructure. So let's do checking of our Terraform code again. I mentioned that it's fixed already. You can see there is QE. Okay, QE is free. Let's refresh. Oh, the final job has failed. And you can see the Terraform apply also haven't been executed. It's okay. We have made some checks for the last job, and we can rerun it again. Also queue, you can see that executing. Let's wait a little time. It has finished, as you can see. Let's refresh. Okay, all jobs are fine, but we can see that the last one hadn't been executed, and the previous are recently finished. Let's go inside. What haven't we forgot? We need to define trigger that will execute the last job. And here we put just the order of checking our Terraform code. The first checker, the second, and the third one. And only after all of these jobs are successfully finished, the Terraform apply will be executed. This showed us the full pipeline of checking security in Terraform code and applying it to infrastructure. Let's do it again. It will take a little bit of time. In general, this shows that we can and we should treat our infrastructure code in the same way as we treat application source code in secure manner. So we can see that TF apply checked is already going, and it's done, I suppose. Let's check. Yeah. So we have deployed our new fixed code. What's the changes? Let's go and check our S3 bucket permissions and what we can do to objects stored in S3 again. Just list them. and we see that permission access is denied. That's why we have granted access only to trusted entity, not to everybody, not to every machine. So let's go to EPAM again, the EPAM site from WordPress. From the first site, it's perfect, but we will refresh our browser and we can see that there is no HTTP error or something like this, just waiting. Let's try again another. Nothing appears, as you can see. What's the problem? The first instance was run fine with HTTP, just let's change it to HTTPS and secure protocol, and it works fine. This shows that access to this site using simple plain text HTTP was prohibited, and just secure manner for the site is approved. So for demo is all. Thanks for listening, for watching. Thank you.